Hello everyone again and welcome to my channel. In here we're going to be looking at the applications of electrocyclic reactions in nature, and it's quite exciting that looking at this particular process where we have this complex structure which actually transforms from this into that by the opening of the ring to form another increase in number of the members in that particular ring, actually leads to another process that pushes this reaction into the opening of this particular ring to form a long chain. Now, this compound in here is known as the Endiandric acid D, and this is actually found in Endiandric trees, and those trees, they actually have this compound that is quite important in terms of antibiotic activities, that is actually making this particular compound to, I would say, more efficient compared to that of ampicillin. Now, let's look at what we're going to look at in here. Now, first of all, looking at this, our first particular compound, this compound, if you recognize this, you see that there's an increase in the ring, members of the ring, and you know that this particular segment here is actually corresponding to the segment over here. That means this particular bond actually leaves, that is, cleaves off. So what happens in here is that we have the breakage of this bond, forming of this bond and reforming of that bond. And what that results is that we have actually a pi system that involves 6 electrons, and these 6 electrons that are actually pi, they do correspond to a superficial state which is determined by our Woodward-Hoffmann law, which states that if you have a particular R or Q, that is 4Q plus 2, which is equal to 6, RQ, which is equal to 1, represents a dissociatory process, because our Q in here is not a decimal, we are getting a whole number, and it's an odd number as well. So what we have going from our beginning step to our big compound is a process called a disrotatory process, where this bond here and this bond here performs a bend in the bond, which is actually going inward in such a way that we're able to break the sigma bond. Now let's look at this in our MO diagrams. So our MO diagrams reveal that, hey, what we got is a big sigma lobe over here, and what we have is that this is shaded, and in here is the remaining part of our ring. And now what we note is that the remaining members are all LUMO in here. So this segment are LUMO, and while this particular part here is actually the HOMO. So the HOMO is the sigma bond, and while the pi system here are the LUMO. Now let's determine our LUMO in phase and out of phase with respect to the number of nodes that are actually present here. So in 4 members, our LUMO, we actually have 2 nodes. We have one here and one there. What that means is that if this is actually shaded, this will be out of phase with respect to that, and this will be in phase with respect to that, and this will be out of phase with respect to that. Now, on the other case here, in our HOMO, what we have is that once you are able to break our bond in here, let me not forget to draw the other species that we have here. So we have shaded, da, 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 boom, 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 boom. And this, don't forget, is actually pointing away from me with a COH, and this other part is pointing towards me, which is our H. Now in here, which is our HOMO part segment, if you break this bond, we do know that for our 6 electrons is dissociatory, so we are going outward in here to break our bond, one going left and the other going to the right. So what we have is a dissociatory case, and what we have is that in here we're going to have in phase with respect to that, and in here we'll have in phase with respect to that, because initially it went on an head-on overlap, which is superficial, but by breaking the bond you're going back to where it was before, which was these two, which are actually in phase with respect to each other. So if I redraw our product, what we have is this particular MO with our other segment of bond. So if I draw this and that, this, so in here in phase with respect to this, and this out of phase with respect to that, this in phase with respect to that, and this out of phase with respect to that, but this is in phase with respect to this one. Now you see now that we're able to generate a HOMO of our product, which is what we have over here, and this other part bond here is actually this one that we have over there. Now what we're going to do next is to be able to go from this to that. Now if you perform another electrocyclic process in here leading into the opening of this ring to reveal our long chain, what we notice is that we are going from this here to that and here. So in total we have 8 electrons involved in here, and what we generate is an 8 pi system. Now the 8 pi electrons actually reveals that, hey, we are actually going in an antirofacial state where the 8 pi actually reflects the 4R from the Woodward-Hoffman, and this reveals that our R equals 2, which is not a decimal. So this makes us to conclude that our process here is conrotatory. Now our conrotatory actually is revealed from this, where this actually changes its MO in a way to form this whole part becoming the LUMO of a 6-membered system, and while this particular part is our sigma bond, which is the target to be broken, and this is actually our HOMO. So let me redraw this by changing the orbital in phase and out of phase process here. So we have these, but now what we have is this, which is actually shaded, is out of phase with respect to that with our node here, but this is in phase with respect to that, but this is out of phase with respect to that with the node at the middle here. This is in phase with respect to this neighbor here, and this is out of phase with respect to that. Then you have our node here. Now this is the LUMO for our 6-membered pi system, and this over here is our HOMO. Now once you're able to break this bond, and we determine this to be our conrotatory process, now what that means is that I'm going either the left or to the right. But if I go to the right, then I'm able to actually form a plane system coming from this in such a way that this will actually go to the right and bring this a little bit upward and this a little bit downward, in such a way that we have this actually 120 degrees with respect to each other here and there. So if I push my bond here and push my bond over there, what I get is my new MO for my new compound to be in this particular manner, where this is in phase with respect to that, but this is out of phase with respect to that, in phase with respect to this, out of phase with respect to that, in phase with respect to this, out of phase with respect to that, and in phase with respect to this. So this is our HOMO for our final product, which is what we have over here. So that's about it for this particular video. I hope you're able to understand how you're able to actually solve various problems, and understanding how you're able to actually determine the dissociatory state from the correlatory state, and how those actually plays a role in not only the stereochemistry of our intermediates, which is what we got over here, but also how that actually reflects on how we form our compounds in terms of the MOs that are actually involved in here, both in terms of HOMO, LUMO, and in general the HOMO. Thanks for watching. Please hit a comment down below, let me hear your thoughts. Thanks for the support. Hit the like, share, and subscribe, and be smart. Bye.